Welcome to another episode of Alibaba Cloud webinars. I am Nuruddin Abbasali and I will be taking you through an exploration journey today. Today's webinar is more apt for the geek that lives inside all of us. We will talk about some basic concepts of an industry-leading open source search engine known as Elasticsearch. Then we will also talk about how Alibaba Cloud makes it easy for you to deploy this Elasticsearch engine on our cloud platform. So this is the agenda for today. We will begin by describing what Elasticsearch is. We will then briefly discuss some of the use cases where Elasticsearch is commonly implemented. Next, we will move to describing the core components within Elasticsearch, and then we will describe how exactly is data stored in Elasticsearch. Towards the second half of the webinar, we will delve into a demo showing a practical use case of searching on Elasticsearch cluster to provide autocomplete functionality on a product catalog. Then we will talk about how Alibaba Cloud makes it very easy for its consumers to deploy and consume Elasticsearch. We will conclude with a demo showing the simplicity of launching a managed Elasticsearch cluster in Alibaba Cloud. That is quite a handful, I agree, but don't worry, we will try to keep it simple, brief, and to the point. Also, do note that, as always, there is a Q&A button at the bottom right for submitting any questions that you might have. You can submit these questions throughout the webinar, and I will try and address as many of them as possible in the Q&A session at the end of the webinar. So what really is Elasticsearch? It is a search engine at the end of the day. It is open source, hence it comes with all the benefits of an open source platform. It is distributed. That means that you can deploy an Elasticsearch on a single node and horizontally scale it to hundreds of servers, with your index data distributed across these nodes. This brings us to our next point, which is quick horizontal scalability of nodes. And the beauty of it all is that irrespective of the cluster size, your mode of interaction with the search remains the same. Don't worry too much at this point about things like indexes and data distribution. We will talk about these later in the webinar and hopefully things will be much more clear. Moving forward, it is an active development project and is being used in a large number of enterprises. It would not be wrong to say that currently the gold standard for search in the industry is held by Elasticsearch along with Apache Solr. And it is really fast. No, I mean really fast. I will try and capture some speed statistics during the demo session. Also note that it is very easy to consume. Why do I say that? Well, the initial learning curve is not very big. There are a handful of concepts that you need to master before you can start playing around with Elasticsearch. It's got an extensive set of APIs that are available. These APIs can be accessed using all major programming languages such as Java, Python, Ruby, Perl, etc. Lastly, it has a large open source community that is constantly developing and improving the product. Okay, so now let us look at some of the common industry use cases for Elasticsearch. The first one, and as you can tell, my favorite one, is autocomplete catalog search. All of us have shopped online for one thing or the other. How often do you go and manually look for products under categories and then subcategories? Almost never. Instead, we go to that really nice search bar and start typing. Ever notice that as we are typing, magically a small list pops up under the search bar? At first look, it might seem very simple, but as you type, in a matter of milliseconds, the application is querying a very large set of products fetching the ones that match your search and displaying it. This is no simple task and is being performed by Elasticsearch or something similar. The next one is more straightforward, where an enterprise uses Elasticsearch for something like archive search, blog search, messaging history search, employee search, or any other search that you can possibly think of. Elasticsearch is also very commonly used as an open source centralized logging system. You can use Beats, which is another open source tool, to ship logs from various sources into Elasticsearch, and then use Kibana, which is a visualization tool, and analyze the log data within Elasticsearch. This one is similar to logging, however, instead of shipping logs, we are shipping events such as monitoring events and other matrices. Again, the same stack, Beats to Elasticsearch and Elasticsearch to Kibana. The process is ingest, process, visualize in the form of real-time dashboards. Now let's say you have a large amount of data sitting in a Hadoop cluster. You could connect this to Elasticsearch to gain insights into your Hadoop data. You could also run graph analysis and machine learning algorithms and visualize the results using Kibana. The list goes on, but I think you get the gist. Let us look at some basic Elasticsearch infrastructure concepts. These will help in understanding what we do during the demo sessions and hopefully will give you a good starting point to start playing with Elasticsearch. Masternodes are responsible for lightweight cluster-wide actions. Now, what are these cluster-wide actions? Creating or deleting an index, tracking cluster nodes, distributing shards across nodes. Now, don't worry, I will explain index and shards shortly. For now, understand that master nodes are responsible for defining the structure of how data is stored, track the health of the cluster nodes, and ensure data is well distributed amongst nodes. Remember, Elasticsearch is a distributed search engine and hence the main focus on distribution. Data nodes hold the data, as the name says. They are also responsible for data operations. Data nodes actually hold the actual pieces, and I will explain shortly of data what these pieces are. All data related operations such as CRUD operations, which is create, update, delete, retrieve, etc., search and aggregations are handled by data nodes. These operations, note, are very resource intensive, hence it is important to monitor these resources and to add more data nodes if they get overloaded. Coordinating nodes act as smart load balancers and are mainly responsible for routing requests. While these can be deployed separately, this function is often handled by master nodes. Logstash is another pipeline tool that can ingest data from various channels, transform the data if needed, and then push it to a stash such as Elasticsearch or something on the lines of Hadoop. Last and definitely not the least is Kibana, which helps you to visualize your data and run analysis such as graph or other machine learning functions. Alright, so as promised, a few basic concepts about how data is stored within Elasticsearch. If you're familiar with relational databases, then an index in Elasticsearch would equate to a database in a relational database system. Data in an index is stored in partitions called shards. While going into details of shards is beyond the scope of this webinar, and honestly I'd need another entire webinar to just explain shards. For now, we need to know that shards allow indexes to distribute data across multiple nodes for distributed access and faster processing. Which brings us to the concept of replicas, which are duplicate shards stored across nodes for high availability. So the gist you got to capture here is that we have a lot of data. This data is indexed, um, and the data is stored in separate partitions. These partitions are distributed across a large number of nodes for faster access, and copies of these partitions are also maintained in case some of those copies go bad for high availability and data resilience. All right. Now let's look at a sample data flow for an e-commerce application uh, if you had Elasticsearch deployed under it. So if you have a e-commerce application user, the application user performs an action on the e-commerce application via the internet. The customer application, what is this action? Now this action could be anything. Let's assume that this action is he starts typing in the search field, right? The customer application sends a search query to Elasticsearch cluster based on the action. This is done via VPN or other connectivity. Now what happens inside Elasticsearch? So till now the query has come to Elasticsearch. The request is received by some form of a load balancer. The load balancer passes the request to one of the coordinating nodes or master nodes depending on how you deployed Elasticsearch. Now this node checks the cluster status and where this particular data is located. Remember, shard is where the data is physically located, and this information is available with the master nodes. Now, once this information is located from the master nodes, the query is sent to the data nodes. The data nodes run the query, and remember, the data nodes are responsible for all data actions, and these are usually the intense IO intense and resource intense activities. So the data nodes run the query and return the result to the coordinating nodes or the master nodes, whichever one have been deployed. The result is then sent back to the e-commerce application, and then the e-commerce application uses the result and displays the relevant information to the user. Note that this entire process needs to happen within a matter of milliseconds. Otherwise, if you're sitting on your favorite e-commerce application, you'd probably switch. One more part that we see is Logstash. Here, Logstash is used to extract raw data from the e-commerce application data source, which is usually a database or a data catalog, and push and update raw data into the relevant index in the Elasticsearch. So this is a simple flow of how you would go about using Elasticsearch within an e-commerce application. All right, time to have some fun now. So for the first demo, what we have is we've pre-configured an Elasticsearch cluster, and we have populated it with a large data set that is indexed within this cluster. We have a simple web application with an autocomplete field. So it's just a very simple application. When you run it, you just see one field, which is an autocomplete. We have also deployed Logstash that we have used to import this data into Elasticsearch, and there is also Kibana dashboard available. So what are we gonna actually do through this demo? We are going to run a few simple search queries using command line. The reason why I'm using command line here is to show you a few features such as AND functions and OR functions while we do searches, and how does that impact our result. Also, we will try something called fuzziness, and I'll explain this during the demo. And then we will look at the sample application and start searching things and see how the application responds using Elasticsearch. All right, so it's time for the demo now, so let's switch to the demo. In this demo, we are going to demonstrate an Elasticsearch cluster and how it is displayed in the Alibaba console. plus a few features of Elasticsearch and also a few features provided by Alibaba with regards to monitoring and managing the cluster. So as you can see here, we are logged into an Alibaba Cloud console. Now, if you go to products and just search for Elastic, here you can see under DT plus you get the Alibaba Cloud Elasticsearch. For the sake of the demo, we have pre-created an Elasticsearch cluster, which I'm going to display to you. So this we have done in the US region, and as you can see, this is the cluster configuration. If you want to see details of what this cluster is about, then we can go inside the cluster. We can see the instance ID, we can see Elasticsearch version, the region, particular zone, billing method, and so on and so forth. You can enable public IP address if you want, but that's not recommended for production. If you look at the configuration, the configuration is 3 data nodes and 3 dedicated master nodes. So in this case, we don't have the coordination nodes, but we have 3 dedicated master nodes and data nodes. As your requirements increase, usually your data nodes are going to start scaling out. If you look on this side, it shows you the configuration for the data nodes and the master node and the disk type for these. Now, a few other things that you can see from here, there's a Kibana console, cluster monitor. There are some restart functions that are available, and since this is pay as you go, you can switch it to subscription billing, which we won't do right now. Now, if you want to look at things like cluster monitoring, then you can go into cluster monitoring and let's see, and here we go. So it will give you things like the status of the cluster, what kind of queries has it been addressing, and node heap statistics, disk utilization, node load, and so on and so forth. So from here you can monitor the cluster, and then you can pull this data for past 1 hour, 3 hours, and so on and so forth. Similarly, you can look at logs. Now this is a testing cluster, so you will see a lot of warnings and error messages, which is fine. So instance log, then you can look at the GC log, which might have some other stuff as well. Slow searching log should be empty. This is also empty. And if you create any snapshots, then those data snapshots would turn up here. Now, so this is the cluster that we are talking about. Now, what we are going to do is we're going to start interacting with this cluster. I did also promise you that we are going to have a log stash. So in order to set up a log stash, what you do is you launch an ECS server. So if you go to instances and we go to Virginia, oh, sorry, no, we go to Silicon Valley, not Virginia. And here you go. So this particular instance is running my Logstash in case I want to import data into Elasticsearch. And note that this is running in the same VPC, Virtual Private Cloud, as the Elasticsearch. So the communication is internal between Logstash and Elasticsearch. So I mean, that's just something I wanted to show you. Now let's start interacting with Elasticsearch. So to start with, what I have done is I prepared a few search queries. So what we did was we populated this Elasticsearch with some product catalog data. So it's just names and serial numbers, which are SKUs for certain products. And then we're going to try to search within that data. Let's start looking at a few queries. I am just going through my, yeah. So this is the first query I am going to search. So this is the curl command. This is the server I am trying to access, and basically, if you look at the search query is very simple. It is looking into the products index. So this, remember when we talked about indexes, so it's looking in the products index. And what is it querying for? It is querying for a name that matches hero. Fuzziness is auto and operator is or. So fuzziness and operator is something that I will explain to you in a couple of minutes. So if we run this query, we get two results, total two. One is DJ Hero 2 and then DJ Hero 2 Nintendo something. So as you can see, as we run the search, we get these results. Now let's start playing around with the parameters. Okay, so now if you look at my operator is set to OR and my search query is Hero 5. Now if I run this query, I'm still getting these two results, although in the name there is no 5. The reason for this is that the operator is set to OR and not to AND. Now if I were to do the same query but change my operator to AND, my results would be 0, because now it's looking for both hero and 5 within the same query. Another interesting thing that you can do is play around with the fuzziness. So let's say we make a spelling mistake. So let's try to make a spelling mistake. This one. Alright, so instead of hero, I have put the query as Hera. So now there is nothing called Hera in my particular catalog, but when I run this search, I still get these two because it takes care of small spelling mistakes, this fuzziness feature. Now if I were to turn off the fuzziness and run the same query again, which is in this case, you will see that I will not get any results whatsoever. Now this is with regards to running the queries on Elasticsearch. Now I did promise you an application, so let's see what we have. So I have a very simple autocomplete application running on Node.js. So I will just run and we have a server that started. So now let's start. This is the application. Let me just refresh it, make sure it's working. Yeah, it's working fine. So now if you look at it, it's the same thing. The queries, I've just given a front end to the queries. So now if I start searching for Duracell, I am getting all these updates, and as I keep adding and deleting, things keep changing. Now if you see, this is, if I put Duracell 5, nothing comes up, but otherwise you have these results, which means it is an AND operator and not an OR operator. Plus if I were to do this, still I'm getting my results, which means that the fuzziness is also turned on. Similarly, you could do other things like energizer. Let's see if we have. So yeah, we have a lot of batteries in here, and then things like SanDisk, and then SanDisk and other things you could search as well. So I just hope that this gives you a feel of how Elasticsearch works in a practical scenario and what are some of the features that you could use during the search queries. This is not an advanced course, so I will not go into too much details about how the queries work and what are all the options, but the idea is to give you guys a feeler about it. Okay, so I think that concludes our demo 1. So moving ahead, right? So now we are going to look at Elasticsearch on Alibaba Cloud. Now you might ask, why would I want to launch Elasticsearch on Alibaba Cloud? If you remember, we talked about the infrastructure components, and if you were to deploy an Elasticsearch cluster, you would have to manually deploy each of those functions, which is a cumbersome task to say the least, right? And then talk about managing them, upgrading them, downgrading them, monitoring them, so on and so forth. So when you use Elasticsearch on Alibaba Cloud, there's no need to deploy anything manually. You just configure your cluster size and the cluster is deployed for you. Also, Alibaba Cloud provides easy scaling of the cluster. So if again you are using an ES deployed manually on a bare infrastructure, you would have to handle scale in and scale out operations yourselves, while Alibaba Cloud provides handy tools to do this with ease. Also, Alibaba Cloud comes with an XPack plugin. So these XPack plugins enable functionalities such as access control, cluster monitoring, visualization, and machine learning by default, so which is fantastic. Note that this is the default ELK architecture, which means that you can use an outside Logstash or Kibana or any combination of these software or other ecosystem software with this Elasticsearch deployment on Alibaba Cloud. So it is completely ELK compatible. Like every other service on Alibaba Cloud, Elasticsearch comes with its set of open RESTful APIs, so all functionalities can be accessed and programmed through RESTful APIs. Now, remember we talked about shards and replicas. When you talk about Elasticsearch, right? So depending on the kind of data and the kind of queries, uh, you need to figure out how your data is distributed and how many copies you want to retain within the system. Now, this complexity, when you deploy with Alibaba Cloud, is managed on the Alibaba Cloud front, so you really don't have to worry about it. Now, a few things that come by default is if you have a secure Elasticsearch cluster, because we provide it within the VPC domain, which means you can create separate tenants and have complete isolation for your Elasticsearch clusters. Do note that this could be your sensitive data that you are indexing, so the security would be much appreciated by most organizations. And also, when you look at the way Elasticsearch is deployed, the nodes come with options of deploying over SSD storage, which we all know is high IO storage. So this would allow especially data nodes to operate at maximum efficiency. There are a lot more features, but these are the salient ones that I felt we should discuss within Alibaba Cloud. So now we would go to last section of this webinar, which is demo number 2. What are we gonna do? The idea of this section is to just show you how easy it is to deploy an Elasticsearch cluster on Alibaba Cloud using the Elasticsearch service. We will go around the console and explore a few options with regards to how you can monitor and manage this Elasticsearch on Alibaba. And also, if time permits, we will look at pre-populated data in Kibana. No, do note that Alibaba Cloud Elasticsearch service comes with a pre-integrated Kibana console as well. So time for some more fun. So let's move to demo number 2. So in this second demo, we are going to talk about deploying an Elasticsearch cluster within Alibaba Cloud. So again, as we saw in the previous demo, go to products and we search for Elasticsearch, and I will continue to use Silicon Valley. But we will not use this cluster, rather we will create another one. So when you create, you have the options to go to subscription or pay as you go. We'll select pay as you go right now. You want to select Silicon Valley, you can select which zone you want it in. Let's keep it in zone A. You can select the XPack version. Let's select the latest one. So if you remember, the XPack is basically what deploys the additional security, authentication, the monitoring, analytics, and machine learning. And then you select which VPC you want to deploy it in and which switch, which is fine. Instance type. So you have lots of different categories. Let's select something small. So let's select 2 core 4 GB, and we need 3 data nodes. So if you look at this particular scenario, it says 2 node cluster has the risk of split brain. If you understand what split brain is, what happens is that if you have only 2 nodes and there is a disconnect between the two, each of them promotes itself as the master, and then you've got virtually got 2 split environments running in one place, and then synchronization becomes a nightmare. If there are 3, then that never happens, because even if there is a break, there will always be an odd and even number. So the one with the majority will select the master and the other one will not promote itself. The default username is Elastic. We first set up a password. And okay, so let's select some dedicated master nodes. This default configuration is okay. We're using SSD and minimal storage on master nodes, because the data is actually stored on the data nodes. Alright, this is the storage for the data nodes. You can select SSD Ultra Disk. In a production environment, I would highly recommend selecting SSD, and then you can select whatever storage you need, and then you go to buy. And this gives you a summary. We say we are okay with the pay-as-you-go agreement, and we activate. Alright, great. So this has been activated. Let's go back, and it's got us back to the main screen. We will go back to our Elasticsearch and go back to Silicon Valley. Alright, so this is an initializing stage. It will take a few minutes. As you can see, this is initializing. This takes around a few minutes depending on what kind of cluster configuration it is, because it's going to launch 6 nodes, and it's going to deploy the specific applications that are required for Elasticsearch, and then it will come to a running state. In the interest of time, what we would do is we will start exploring some of the options under the console, and also look at Kibana. So while this one is, let's try to explore it while it's initializing. So it's in the initializing state right now. Obviously the cluster monitoring is not going to fetch you any data. We did see this in the last demo where we were getting data from it, and obviously the logs are going to be empty. Now we did know that the previous one cluster was updated with some data, so this gives us a good chance to start looking into those data options. So if you log into Kibana console, Kibana basically is the visualization layer for Elasticsearch and the ecosystem around it. There are lots of options here. Let's start with the management. So in the management, what you can do is you can look at the different types of users. I've created one for myself. It's a Logstash user to move data in, and there are different kinds of roles that you can associate with a user. So this is the user control. Then if you go into monitoring, basically it tells you the overview, what kind of nodes are deployed, what kind of indexes. So let's start looking at the nodes, and this gives you the detailed status of load, JVM, so on and so forth, of the different nodes that have been deployed for this. Now, if you go back to the overview, this again tells us the different search rate, latency, indexing, and so on and so forth. One more thing I wanted to show you was the indexes themselves. So if we come here, these are the indexes. This particular one is the index that we created for our particular scenario. There are some search queries in here that you can see as well. Similarly, you can go to Discover and you can actually look at the data that is sitting inside Elasticsearch. So I mean, this is some of the data, or a snapshot of the data that is visible. So you can see there's a name here for some, and then there is something called SKU. So let's see if we can, and here we go. We've got our Duracell batteries, and if we go further down, we can find other things as well. So this hopefully gives you an idea of how Elasticsearch works and how easy it is to deploy Elasticsearch in Alibaba Cloud. If I go back to this environment, it's still initializing. It's been almost 5 minutes now. I think it takes around, for an environment this size, it could take around 12 to 14 minutes to initialize, but once it's done, then you have an Elasticsearch cluster up and running. I hope this was an interesting demo for you, and it shows you how easy it is to deploy Elasticsearch using Alibaba Cloud. This concludes the presentation section of the webinar, and now we can move to the question and answers. So thank you everyone for joining in. This is the Q&A session, and I received a couple of questions, so let's try to answer them. So the first one that I received was, which Elasticsearch version does Alibaba support, and how about Logstash? So the first part, currently Alibaba Cloud provides plugins for Elasticsearch version 5, 5.3, and 6.3. So these are the two versions that are supported. Logstash is currently not provided as a managed service. However, it can be deployed on an ECS server in Alibaba Cloud and can interact with the Elasticsearch cluster service, which we have been talking about. A guide to setting up Logstash for the service is provided under best practices in the documentation for Elasticsearch on the Alibaba Cloud documentation page. I hope that answers the question. The second question that was raised was if you could tell us what is Elasticsearch based on and what are the competitors, and why would you choose Elasticsearch over other open source search engines? All right, so there's got three parts to it. I will try to cover them briefly. Elasticsearch basically is based on an open source project called Lucene. So this is an open source search project based on which Elasticsearch was created, which again is also open source. The main competition for Elasticsearch at this point in time is Apache Solr. And this is another open source search project, which as far as I know is also based on Lucene. So they're quite similar in that. Personally, I think Elasticsearch has a much richer integration ecosystem, and the company behind this project has taken the idea of search and extended it to analytics and problem solving, which for me makes for a better choice. So seems like these two questions were raised during the webinar. I hope I have answered them to your satisfaction. Just a quick reminder, a video recording of this webinar will be made available for future viewing on the Alibaba Cloud website in 24 hours. So once again, thank you very much for joining in, and have a great day ahead. Thank you.